All right, so in 7.1, we talked about finding rational solutions. Those were solutions that could be written as a fraction. Today we're talking about finding complex solutions, which means we're going to start including irrational solutions and imaginary solutions. So just kind of think back, you're going to see this. We're going to have things that still have a square root in them, so numbers that can't break down, and then imaginary means we're going to have things that have I in them. And remember, I is equal to the square root of -1, so when you have a negative inside of a square root. All right, so I'm going to show us 3 different cases. I just want you to watch, and then we're going to take notes at the end. So you don't need to take anything right now, just watch the video. So in this problem, they factored out a GCF, and if you look between what they've given us, the GCF here is x squared. What I want you to recognize is that you know how to name all of the roots here. So x squared, that's actually, the root is 0, and it's a double root at 0, right? That's something that's going to bounce. So because it's squared, I'm actually going to list 0 twice. And then plus 7, you know that's going to give me -7. So the things I want you to notice, because this is x to the third, I have 3 solutions, 1, 2, 3. Even though the 0 is listed twice, it still counts as 3 solutions. So this is 3, and they're all real solutions. So all of those are real numbers. There's no square roots or imaginary, anything like that. All right, our second case, we learned before how to do difference of cube numbers. So up here, if you take the cube root of -64, you get x minus 4. And remember our pattern, we square the first, square the last, multiply and change the sign. So that's going to give me plus 4x. And we learned before that this doesn't factor. So because it doesn't factor, I'm kind of skipping ahead of myself, but because it doesn't factor, you'll notice that in this section, they're going to use the quadratic formula to factor that. So we'll talk about that more here in a minute. The real solution, though, this first parenthesis does have a real solution, and that is positive 4. So I'm going to pause and fill in the numbers and just remind you of quadratic formula and then talk about the other 2 solutions. Okay, so I want you to focus on where I am here in this green box. I had -48 in the square root, so I broke that down. Remember, -1 becomes I, and then we're going to make pairs to pull out other whole numbers. So I've got a pair of 2s, a pair of 2s. So far, I've got I times 2 times 2. My square root of 3 is still stuck on the inside because it doesn't have anything to pair with, which means I've got 4I. And notice what they did here to get to my final answer. They looked at your whole numbers. So -4 and 2, you can divide that by 2, and then you can also divide 4 by 2. That's how they're getting -2 plus or minus 2I square root 3. We don't have to worry about the square root because I'm not going to be able to divide it by anything because it's stuck. So my non-real zeros, so these are non-real because they have I in them, my non-real zeros are now -2 plus 2I square root 3 and -2 minus 2I square root 3. So I want you to recognize here that we still have 3 solutions because it's to the third. We have 1 real solution and 2 non-real solutions. And I hope that you recognize or start to recognize that these are conjugates. Remember, conjugates look the same except the sign in the middle here is different. All right, last little example. This one is x to the fourth. We had one kind of like this on a test. So it says difference of squares, which means I need to split my numbers. So x to the fourth splits to be x squared and x squared. And -16 splits to be -4 plus 4. If you recognize this right here is not difference of squares, so we're going to have to do something with that here in a minute. This one is still difference of squares, which means I can factor again. So difference of squares. So if I factor this one again, I'm going to get x plus 2, x minus 2. The x squared plus 4 doesn't factor. And now I can start naming my roots, which is mostly what we're doing today is just finding all the roots. So I have a root here at -2, +2, and if you know you can't factor it, you either need to do quadratic formula, or you may be able to just solve pretty simply. This is x squared. Remember, like way back in freshman year when you learned this, you set them equal to 0. So if I solve, I'm going to -4. This is x squared equals -4. I can take the square root. Because it's a negative number, that means I'm going to have an I in my answer. So this is +2i and -2i. So now I still have, this is x to the 4th, so I should have 4 solutions, and I do. -2, +2, -2i, and +2i. All right, so now is where you want to actually start taking notes. So the things that you want to take note about. Okay, the first thing is that the degree tells you the total number of solutions. Irrational roots come in conjugate pairs. So an example of that would be if you had like, let's see, 2 plus the square root of 7, 2 minus the square root of 7 would also be a solution. And lastly, imaginary roots come in conjugate pairs. So an example of that would be something like 4i and -4i, because those are opposite from one another. Okay, so example 5 here is going to be our first example. We're going to do 6 at the beginning of class tomorrow. So you copy it down. So for this one, you want to copy it, but leave yourself some space so that we can work that one together tomorrow. So on the first one, they want us to find all of the roots, which means I need to have 3 answers because this is to the 3rd. Hopefully you notice that that is difference of cubes. So I'm going to go ahead and set up. I've got a short parenthesis and a long one. The cube root of 8 is 2, so this is 2x. The cube root of -27 is -3. That you could get that in your calculator by doing the cube root in the math folder. All right, so we're going to square the first, square the last, multiply and change the signs. That's going to be plus 6x. This first is always going to give me a real root. And if you aren't sure maybe how to see that as an answer, you can set it equal to 0 and just solve. Divide by 2, so x is equal to 3/2. One thing another way to do that is to think about, those of you that like bottoms up, think about if this came to the front, where was it to begin with? Well, it would have been underneath here, and the opposite of -3/2 is +3/2. So just that's maybe another quicker way to kind of think about that. So this is one of my roots, x equals 3/2. I know I've got 2 more left to find. We talked about how this will never factor, which means you're going to have to do quadratic formula. So I want you to pause and take a minute to work out quadratic formula, and that's the song x equals -b plus or minus square root b squared minus 4ac all over 2a. All right, so after my first step I've gotten here, now I need to take a minute to break down this square root. So I'm going to pause and break down the square root of not 180, 108. And now that I have it broken down, I'm going to start pulling some numbers out. So I know -1 is my I have a 2, a 3, and this last 3 is going to be left over in my square root. So when I rewrite this out, I'm going to have -6 plus or minus 2 times 3 is 6i square root 3. I got the 6 because I'm doing 2 times 3 here, and then all over 8. And if we look at our whole numbers, so I'm looking at my -6, my 6, and 8. What can I take out of all 3 of those? I can take out a 2. So if I divide all of that by 2, I'm going to have -3 plus or minus 2i square root 3 all over 4. And you don't need to write those as 2 separate roots. I just want you to recognize that because this is plus minus here in the middle, one of the roots is adding, divided by 4, and the other root is subtracting. And we can't even get a real answer, so we just have to stop there. But that is 1, 2, 3 answers, so I know that I'm done. All right, last thing they're going to ask us to do is to write a function. These are actually way easier, and I don't even want you to have to multiply it back out. So I just want you to remember, anything that has imaginary is going to have a conjugate. So if 2 plus 3i is a root, then that means 2 minus 3i is a root also. Again, because this has irrational, it also has conjugates, which means 4 plus 7 square root 2 is a root also. So this is going to look kind of crazy for a minute, and we're going to simplify it here in a second. My first root is going to be, I want to subtract this, so I'm going to write, if that's a root, it's x minus 2 minus 3i. And then I've got the root here. This is going to give me the factor x minus 2 plus 3i. You may be wondering why I'm changing the sign. The reason is because I'm distributing a negative, because I know I have to change the signs. So the same way you change the sign, it's like opposite. I'm doing that same kind of concept here. Okay. Up here, my 4 minus 7 square root 2 becomes x minus 4 plus 7 square root 2. And then my last root, let's see, my last root is going to come here, and it's going to be x minus 4 minus 7 square root 2. And for right now, technically this question is wanting me to multiply all of this out so that it looks a little bit simpler. Oh my gosh, let's not do that. That seems really, really hard. So the biggest thing I want you to be able to do is notice when there are zeros that they're telling you about that are secret, right? These are like secret zeros. You have to remember to create the conjugate to have a second one, and also to use opposites when you write your factors. So when you do this problem tomorrow, we can leave this as our answer if our problem looks this complicated, and we'll kind of work that out tomorrow. Okay, so remember, this is the problem I want you to have copied. It's where we're going to start tomorrow, and we're going to use our calculator to do some things to make these problems just a little bit simpler so we don't get lost in all of the process.